Hello. In this video, we're going to be looking at functions in Java, and specifically the main function. Another word for function is method. So if you hear me say the word method or function, just realize those are interchangeable in Java. So today what we want to do, if you look at the targets, is understand what we use the main method for. And then additionally, we're also going to look at how to generate random numbers using the math class and the random method within the math class. And we're also going to learn how to retrieve input from the keyboard using what's called the scanner class. The vocabulary you see below matches up with our Unit 1 vocabulary. We've got function / method. Again, those are synonyms in Java. We've got a return type. Return type means the value that the function gives back as a result. And then parameter and argument. Parameters are the variables into which arguments are passed. What I mean by that is when we call a function, if you have something like f of x, let's maybe write this down. If I have f of x in math or in programming, that x is what we call the parameter. Our book, CS Awesome, calls these formal parameters. So you might see that in the reading. So formal parameters. If you then use the function, right? If we make a function call is how we say that. And we say something like, what is f of 3? Well, then the 3 is an argument. Our book, again, calls these actual parameters. So if you see the word actual parameter, that is the same as what I usually call an argument. Okay, so these are the things we want to focus on as we go through the notes today. Let's look now at how we declare a function in Java. A function declaration is simply the line that creates the function, if you will. So if you are used to Python, what that looked like was we used the keyword def, right? So this is a Python function declaration. We might have def foo, and then maybe a couple parameters that function would accept, and then the colon. This would be our function declaration, followed then by the body of the function, which we'll ignore for now. Again, that's a Python function declaration. In Java, this is not done the same. It looks pretty different, actually, and there's some other things that we have to concern ourselves with. So in a Java function declaration, we begin with what are called modifiers, and we'll get into that in a little bit. Okay, and the angle brackets here around the word modifiers just indicate that we don't actually write the word modifier. This will be filled in by the actual modifier words, which we'll talk about, followed by the return type. Again, the return type is the type of information that the function gives back as a result. Maybe that's an integer, maybe that's a string, could be any number of things. Following the return type, we have the actual function name, whatever we're naming that function. In this case, that might be foo, right? So we'll look at that in a sec. And then following that, we've got parentheses and then the parameters, followed by another parenthesis. Okay, so as an example, if we were going to define this function foo, it would look like this in Java, potentially. We might make this a public function. That word public is new. Don't worry that you don't know it yet. The return type, let's say it returns an integer, right? It calculates something and returns an integer. So we would say int. Again, that could be something else if the function had a different purpose. The name of the function is foo. And then the parameters were a and b. Well, in Java, when you specify the parameters, you don't just specify their names like a and b. You also have to specify their types. So maybe, for instance, maybe a is an int, and maybe b is a string. I'm just making up these types to illustrate an example. Of course, depending on the purpose of the function, you would have different kinds of parameters with different types, etc. Okay, but this would be an example function declaration in Java, and you can see it's a lot more syntactically heavy, if you will, than a Python declaration. There's a bit more going on that we have to kind of parse and understand. So First of all, let's look at these modifiers. So all these words up here that you see, public, private, and protected, these are examples of modifiers. We didn't have modifiers like these in Python, and what these particular modifiers, what they do is control access to the code that we're looking at. So we can define a function that's only accessible to certain other parts of our computer program, and that's how we manage this, is through these particular modifiers. I don't want you to overly concern yourself with these right now. We're going to study them a lot more deeply in Unit 2 and then a later unit. So just now I want you to be aware of them because you have to, you'll see them, and I don't want them to confuse you. But for now, we'll just list what they do, and don't worry that it might be a little bit unclear. The first one we've got, and the one that you'll see kind of most often, is public. And all this means is that the code in a public function or any block of code that's public is accessible or visible to all other classes. That means that any piece of code can reference, we'll say visible, can reference a public block of code. So accessible or visible to all other classes. You will not be tested on these modifiers at this point. That will come later in the year. But again, I just want you to be aware of them so that it's not confusing when you see them. The next one we're going to look at is called private, right? These seem to be opposites, public and private. A private block of code, maybe a private method, for instance, is accessible only to the class in which it is declared. Okay? So it can only be used or referenced in a class in which that entity is declared. So if I have a function inside a class and that function's private, then only other functions within that class can call that private function. This applies to variables too. You can have variables in a class that are private, and we'll see that a lot more frequently actually. This is unfamiliar because in Python, if that's what you're coming from, we did not have a notion of public and private variables and functions. They were all, if you will, public. The third modifier is called protected. And protected means that we can access this entity by any class in what's called the same package. We'll get into that later. A package is a collection of classes that are grouped together because of their function. And I do recognize that this notion of class and package and all these new words, you might be listening to this and think, I have no idea what he's talking about. That is okay at this point. I just want to reference these words because you'll see them in code, and we will delve much more deeply into them as the year goes through. You can also have no modifier, in which case the accessibility extends to every class in the package and all what are called subclasses. Again, that's new, so don't worry about that. I just want to have this as a reference for later, so that when this makes sense, you can come back and refer to it. So accessible to all classes in the same package and all subclasses. And those are our accessibility modifiers. There are only those three. In addition to those, we also have a couple other modifiers called static. Actually, it's only one modifier, static, and it's either static or not static. And this refers to, again, methods and variables. This is also going to be a little bit confusing because it's brand new. But again, don't be intimidated by it. I just want you to be aware of it so that when you see it, you know kind of what it does. Okay? And so this static modifier simply indicates whether or not the thing following the word static belongs to the class itself, which is like a type, or objects of that class, which are the actual sort of variables. Okay, so, and I'll give you some examples so that that makes some more sense rather than just what I'm saying. Most methods and variables that we look at are not static, and so you won't run into that too often. But you do run into it in our first method, which is the main method, and so we need to talk about it now, right? As a quick example, let's look at a couple different uses here. So imagine we have a string. So I'm declaring a string variable. And let's say it's someone's name, okay? String name equals, and we will pass in a name here. Let's say Isha. Okay, so now I have this variable name. Well, the string class, okay, so we've got this string class. Name is the actual object. So let's make that specific. Class and name is the reference to the actual object, Isha, okay? This is an object reference. Well, if I want to know the length of Isha's name, which I can see is 5, I can use the string method length, okay? But that length is different for every different name or every different string, right? So that length method doesn't belong to the string class. It belongs to the instances or the objects of those strings, right? Otherwise, every string would have the same length, which makes no sense at all. Tim is only 3 letters. Isha is 5 letters. We would not want the length method to return 5 for both of those different strings. So when I use the method length, I'll show you that here now. The way that I use it is to use it on the object itself. So I would say name.length. So what I'm doing now is I'm invoking or calling the length method on the string Isha, right? Now this would give back, if you will, a 5. Okay, it would return a 5. That is an example of a non-static function. Okay. In contrast, we have a class called math, okay, that has all the interesting math functions we might want to use. So let's say I wanted to use, I wanted to find the sine of, pi over 2 or something, or the sine of some angle. Well, I would use the sine function, but the sine function for you and the sine function for me and the sine function for everybody else always does the same thing. So I don't need to create a brand new object called math or of the math type, because math is the same for everybody, as opposed to the name. Everybody's name is different. So the way I would use the math sine function is to use the class name math dot sine and then whatever value I want here, 0.27. Okay, and this would give me whatever that actually is. I've just made up that value, 0.27. But the point here is that this is a class name, and it turns out that the sine function is a static function, or static method, because it belongs not to the objects but to the class itself. Now let's take a look at the anatomy of a function call, which we also call a method invocation. And so in the previous slide, we actually had 2 function calls. We had the length function, which is a method of the string class, and we had the sine function, which is a method of the math class. And of course, the math class were static methods, where the string class had non-static methods. But they have some things in common, and we want to see the pattern, the generalization of those commonalities that we can use to sort of help us when we see function calls in other contexts to realize what's going on. So I'm going to start with those 2 examples and then generalize from those. So the first call we had was name.length, where name was a string. And this length function is a non-static function. We also had math.sine, and the sine function had an argument. And in each of these cases, there are some similarities and there are some differences. And so let's do the generalization here. What we've got in both cases is we begin with either a class, which is this math class example, or an object reference, which is the case in the name.length example. Name here is the object reference. Okay, and then in either of those cases, we follow that up with a dot and then the function name. So In the first example, that was length. In the second example, that was sign. After the function name, we have the parameter list, so a parentheses, and then any parameters or arguments. Actually, I should say arguments here, right? Because the things that are in the parentheses in the function call are the actual arguments, not the parameters. So we've got arguments here to the function, which of course fill in the parameters that are declared when we created the function. And so this is the general anatomy of a function call or a method invocation. And so if it's a class, that's a static method that we're calling. If it's a object reference, it's a non-static method. And this brings us to the main method, which is really the motivation for this entire preceding portion of the lecture. Is we have a function that Java applications always begin with, and that is the main method. And this isn't up to us, this is just the way it is. And the main method has what's called a signature, which is just its declaration, that looks like this. And again, we don't have a choice about this. This is just what it must be for Java to recognize it. Public, so we've talked about that modifier. Static, meaning that this main method belongs to whatever class it's in and not to objects of that class. Void, which we've not talked about. Main, and then the parameters, strings, square bracket, args. Okay, that is a lot of stuff, right? And so rather than just throw that all at you at once, I tried to introduce those modifiers and the sort of the pattern of function declaration so you could kind of try to make sense of this, even given the fact that you haven't seen all of it before. So what am I trying to say by that? Well, we talked about public and static and that those are modifiers. The next thing we come to here is this word that we've never seen, void. Well, what the heck is that? Maybe I don't know what that is, but if I go back to the slide where we talked about function declarations, then maybe I can at least figure out what kind of a thing it is. Okay, and this is why I want you to know these patterns, right? Language is all about patterns, and understanding language isn't just about knowing a bunch of words. It's knowing how those words interact with each other and fit together to form larger ideas and larger thoughts. And if you can see those patterns, then you'll understand the thoughts better than just trying to memorize a bunch of words. So right here in the middle, we've got the pattern for a function declaration or function signature. Modifiers, return type, name of the function, and parameters. Well, public static void main, we know public static are modifiers. We know main is the name of the function, so that void must fit into this return type slot, okay? And that helps me understand what that is, okay? I've never seen that word before, but okay, I realize it's a return type. All right, so back to main. That void is a return type, and it specifically means it's the keyword we use when we're not returning anything. So functions that don't return values at all are of return type void. So this just signifies that this function returns nothing. And that's okay. That's pretty common for functions that just perform a behavior without giving back any kind of an answer, right? And that's what this is. So this is our function that we always begin with, and I just want to talk about some important points about it. And so we'll put some bullet signs here. Again, this is the starting point for all Java applications. So every Java application must have a public static void main in it as the starting point that Java runs initially. Okay. Also, this is the function generally that is used to set up the rest of the program. What I mean by that is it creates any objects that will be interacting inside this program and that kind of thing. It's typically pretty short because it just kind of sets things up and allows the program then to interact with the user and with the other portions of the program that have been created. And so, and all I mean by short is that it generally doesn't do a whole lot in an actual Java application other than get things up and running, creating variables and all that kind of stuff. So in the beginning of our course, we'll be using main quite a bit just to learn the language and do a lot of things in main. But as we progress through the language, main will be sort of less important other than kicking things off. Any other things that we might want to talk about here might include this, the parameter type here. We've got strings and then square brackets, and that isn't something we've talked about, and we'll talk about it in the future. That just means a string array. So an array is, if you're coming from Python, an array is analogous to a list. So args is just the variable name, and so this args variable is representing a list of strings or an array of strings that would be information that you might want to send into main as sort of optional things. We will pretty much never use it, so I don't want you to worry about it. Again, I also recognize that this public static void main string args can be pretty intimidating to look at. There's a lot going on there, and I don't want you to be intimidated, but I did want to briefly explain it a little bit so that you could start to get a sense of what it means, and you can come back to this as we get a better understanding of these things.